The design of FPCB involves overcoming various challenges, such as quality issues caused by drill offset, misalignment, and stress concentration. To effectively address these problems, one technique stands out: the use of teardrops. PCB teardrops are a design feature where the intersections of traces, pads, or vias on a printed circuit board gradually narrow or widen, forming a teardrop-shaped connection. Sometimes, these teardrops can take the form of snowmen, which are created by connecting two circular pads with a narrow trace in the middle. The purpose of these teardrops is to provide additional copper area, facilitate smooth transitions, and distribute stress more evenly. Teardrops perform exceptionally well in enhancing the performance of plated through holes and their connections, thus improving mechanical and electrical reliability. When drilling holes or vias on a PCB, material expansion and contraction can cause misalignment between the drilled holes and their corresponding pads. Teardrops mitigate this issue by gradually shrinking the pads or traces towards the drilled hole, providing a larger landing area for the drill bit, and addressing overall material dimensional changes and interlayer alignment deviations. Additionally, in cases where vias or pads connect different layer traces, the teardrop shape provides a certain level of tolerance, ensuring sufficient connection area even in the presence of slight interlayer deviations. This significantly reduces the negative impact of material expansion and contraction on the electrical and mechanical integrity of the connections. Another important function of teardrops is to reduce stress concentration at junctions, especially where thin traces intersect with pads or annular rings around through holes. These stress concentrations can lead to issues such as solder joint fractures, pad detachment, or through-hole cracking. Teardrops achieve this by providing a gradual transition from the wide trace width to the narrower connection, reducing stress concentration and offering stress relief by avoiding sudden changes in geometric shapes. Additionally, teardrops act as reinforcements, enhancing the structural integrity of the through-hole pads and vias. This reinforcement ensures that the PCB can withstand various environmental factors, temperature fluctuations, and physical stresses, further enhancing its reliability. In special circumstances, such as in flexible PCBs, the significance of teardrops becomes more pronounced. The flexibility of the PCB can create stress points at the intersections of traces and pads. By incorporating teardrops in the layout of flexible PCBs, the traces and pads can withstand stress during bending and flexing processes without experiencing significant stress-related issues. Teardrops are not only applicable to flexible PCBs but also to high-speed designs, fine-pitch component layouts, and situations involving through-hole connections in high-stress or high-density areas of the PCB. Their versatility and efficiency make them valuable tools for PCB designers facing various challenges, ensuring reliable and robust connections.